Today we're going to talk about simplifying algebraic expressions. An algebraic expression is in simplest form when it has no like terms and no parentheses. There are two steps to simplifying algebraic expressions. The first step is to distribute. And right here, I'm going to put when needed. Because as we get further into solving equations and simplifying expressions, you're not always going to need to use the distributive property. Sometimes you'll need it, sometimes you won't. So when needed. And step 2 is combine like terms. Now, we are going to talk about each step individually. We're going to first talk about distributing. What do you do when you need to distribute? First, what is a constant? It is a number with no variable. Our example, 2x plus 5. Positive 5 is our constant. The other definition is coefficient. The coefficient is the number multiplied, and you can abbreviate, to the variable. So I'm going to use the same example. 2x plus 5. 2 is the coefficient, the x is your variable, and the 5 is your constant. Let's go to example 1. On example 1, we are going to distribute. Now, if you missed the notes on properties, we talked about how the distributive property is the number outside the parentheses is multiplied to the expression inside the parentheses, right? So what is outside my parentheses? I have 8 outside the parentheses, so I am going to multiply 8 to the terms inside. So the first thing I want to point out is this x. This x appears as though it doesn't have a coefficient, but it does. What is the coefficient possibly? Does anybody know? 1. What is it? It's a 1. There is a 1 in front of any variable. Any variable that does not have a coefficient, the coefficient is 1. So we are doing 8 times 1x. What is 8 times 1? 8. So what would 8 times 1x be? 8x. Good. So now I'm going to go back and distribute to the second number inside my expression. 8 times 5. Now, both the 8 and the 5 are positive. So you have positive 8 times positive 5, which gives me positive 40. Now, I'm going to take those two sections and I'm going to put them together. My final answer here is 8x plus 40. Does anybody remember why there is a plus sign in the middle? The 40 is positive. Remember, the sign in the middle belongs to the number behind it. So this plus sign is here because the 40 is positive. All right, let's go to the next one. Let's go to example number 2. So we have a new term on the outside, which is what? A new number. What is this? Negative 4. We're going to multiply it to what? 2x. So negative 4 times 2x. What is negative 4 times 2? Negative 8. Negative 4 times 2x would give us what? Negative 8x. Good job. So now I'm going to do negative 4 times this sign belongs to the 9. It is a negative 9. So negative 4 times negative 9. Positive 36. Why does that positive matter? It determines the sign in the middle. My final answer is negative 8x plus 36. Now that was step 1, us talking about the distributive property. So step 2 was combining like terms. Before we get to combining like terms, we need to talk about what's a term, what's a like term. So let's talk. So I have a couple of definitions here for you. First, what is a term? The terms are the sections of the expression. So we're going to look at the example, 2x plus 5. Now, your terms are separated by the addition and subtraction signs. So this 2x is one term, and this plus 5 is another term. This is a two-term expression. It has two terms. Next one, like terms. How can you determine what's alike? So here, what are like terms? They are terms with the same variable and exponent. I'm going to give you guys a very simple example. 2x squared and 3x squared. What makes these alike is the x squared. They both have an x and they both have the squared. Same variable and exponent. The coefficients, those don't have to be the same. Just the variable, just the exponent. Okay, let's look at the next example, example number 3. First thing we're going to do is identify all the terms. So I'm looking at 9x minus 2 plus 7 minus x, and I'm going to just write my terms down. My terms, I'm starting with 9x, and I'm going to go in order. What is the next term behind 9x? Negative 2. Very good. What is the next term? Positive 7. Now, you don't have to put the positive. It's assumed. And the very last term? Negative x. We are now going to identify the terms that are alike. Always start with the variable. I'm going to start with 9x. What is the other variable in this expression that is like 9x? Negative 1, that's a windy one, x. We have two more that are alike. Negative 2 and positive 7. So now we have our like terms. 9x, negative 1x, negative 2, and 7. We are going to take these like terms and we're going to combine them. I'm going to take my 9x and I'm going to add it to negative 1x. Then I'm going to take my negative 2 and I'm going to add it to 7. So let's do this side first. 9x plus negative 1x is 8x. So now let's do the other side. What is negative 2 plus 7? Positive 5. So now we're going to take these two and we're going to put them together. 8x plus 5. All right, let's do the next example. Again, we're going to identify the terms. We're going to start with z squared. That's my first term. Positive 5z. What's the next term? Negative 3z squared. My last term is 1z. These are all my terms. Now, we're going to jump right in and do like terms. Is anybody still writing these terms? Okay, we're going to do terms that are alike, and we are going to start with z squared. What is the other term? Remember, like terms have to have the same exponent and the same variable. Negative 3z squared. Very good. Because that sign belongs to the 3. So now we're going to do the other one. Positive 5z. Positive 1z. The one that you put in front of the z, we're only using it for calculation purposes. Combine the terms. So now we're going to put 1z squared plus negative 3z squared. 1z squared plus negative 3z squared is negative 2z squared. 5z plus 1z is 6z. Now, what kind of 6z? Positive. So what is my final answer here? Negative 2z squared plus 6z. And I cannot add these two together. Why not? One has the exponent squared and the other one does not. You cannot add them together. It doesn't matter that they have just the same variable. They have to have the same variable and exponent. Yes, sir. All right, here we go. Now, remember I told you guys at the beginning, there are two steps. There are two steps. One, distribute, step 1, and step 2, combine. We have talked about distributive property, and we just finished talking about combining like terms. Now we're going to put those two steps together. Let's first write down our steps. Distribute, and step number 2 is combine. Remember, when we talk about distributive property, remember there's a number in front that you have to multiply to the terms on the inside. Is there a number in front of the parentheses here? 3. Very good. We have to multiply that. 3 times, what's in front of that x that you cannot see? 1. So this is 3 times 1x, 3x. And then I have to go back and do 3 times negative 2, negative 6. So I'm just going to put minus 6. Now, there is also a windy 1 in front of these parentheses that we would distribute, but identity property tells us anything times 1 is itself, right? So does it make sense for me to do 1 times 2x when I know I'm already going to get 2x? Do I need to do all those extra steps? No, so I'm just going to bring down the positive 2x and bring down the positive 4 because they're being multiplied times 1. Now we're going to do step 2. We know distributive property is done because there are no more parentheses. So now we're going to do step 2, combine like terms. Start with the variable. What are my two like terms with a variable? 3x and positive 2x. So that's 3x plus 2x. 3x plus 2x is 5x. My other two are negative 6 and positive 4. Negative 6 plus 4. Negative 2. So my final answer here is what? 5x minus 2. Okay, so here we have example 7. The other two examples, we were finding the sum. So we were adding linear expressions. Now we are subtracting. We have to find the difference. So let's look at this very first expression. Again, is there anything in front of this expression that needs to be distributed? No. So I can just pull these out of the parentheses. 5x plus 6. So now let's look right here. Right behind this subtraction sign, what is right there? A windy 1. Right in front of your x is another what? So you can't see it, but you have to know it's there. Now I'm going to ask, we're looking at this expression. Do you see something that needs to be distributed?
Yes.
Yes. The negative 1. Negative 1 times negative 1x. Positive 1x. Now we're going to do -1 times 6. It is -6, and we're going to write it as -6. Make sure you write the steps at the top. Step 1, distribute. Step 2, combine like terms. Okay. You know you're finished with distributed property when there are no more parentheses. Let's go on to step 2, combine like terms. Start with the variable. 5x. What is another like term in this expression? Positive 1x. Very good. So 5x plus 1x. 6x. Now we're going to combine 6 plus -6. You could put plus 0, but the identity property of addition says anything plus 0 is itself. So do I need to write the plus 0? No. Just 6x. That's your final answer. Number 8. Again, we're going to put our steps at the top. Distribute. Combine. Now, look at the first expression. We're going to start with 5 times 3w. Positive 15w. Now we have to do 5 times 4. Positive 20. So now let's look at this expression. What is in front of this side that needs to be distributed? -2 times, what's in front of that w?
1.
Very good. So it's -2 times 1w. -2. So I put -2w. Now I do -2 times +2, -4. All right, so now on to step 2. Let's combine like terms. Start with 15w. What is the other variable? What is the other term that is like 15w? -2w. Good job. Plus -2w. 13w. So now we have to do constant 20 plus our other constant -4. Positive 16. Remember, you know you have simplified when there are no like terms. And are there any parentheses? This is your final answer. So here we have simplifying algebraic expressions with substitution. So basically, I'm going to teach you guys how to take a given value and plug it in for the variable. Okay, so substitution is to plug in or replace. And it says a value with a given value, but I want you guys to mark off value, and I want you to put replace a variable with a given value. That word should have been variable. So plug in or replace a variable with a given value. Let's look at this first example. 2 times the sum of 5x plus 4 squared when x equals 2. Notice they told us that x what? So every time you see x, you're going to plug in 2. So 2 times 5, plug in the number 2 with parentheses. Always use parentheses. Plus 4 squared. Now we're just using gems. We're back to order of operation. Gems, PEMDAS, whatever you prefer, but order of operation. So we're at G. Do you see any grouping? Yes. We're going to start right here in the middle where these parentheses are. What is 5 times 2? 10. Got to add 4, which is what? 14. So now I'm going to bring down this 2 and bring down the squared. So now it's 2 times 14 squared. 14 squared. 196. So that's 2 times 196. And then that very last step, multiply by 2, 392. All right, let's look at example number 10. So this one says m times the sum of 3n plus p squared when m equals 1, n equals 2, p equals 3. So what am I going to do for these three variables when I see them in my expression? I'm going to plug them in. So m is what? 1 times 3. And 3 is being multiplied to what number? 2 plus p, which is what? 3 squared. We are back at gems, grouping, exponents, multiplication, division, addition, and subtraction. So I have this grouping right here. Inside, I have to start with the multiplication. What's 3 times 2? 6 plus 3, 9. Bring down our 1, parentheses, and bring down that squared. 9 squared.
81.
So I have 1 times 81, which equals? Good job. So I want you to do example 11 on your own. Okay, your first step should have been to plug in -2. 6 times -2 minus 10 times -2. Now we're following order of operations. There's no grouping. There's no exponents. 6 times -2, -12. Look at the 10, not as 10, but as a -10. And do -10 times -2. Positive 20s, -12 plus 20. Positive 8. Good job, guys. Last example, very last one, and we are done. So it says 2 times the difference of x squared and 2 plus 3x squared when x equals -1. First, we're going to substitute by plugging everything in. So every time I see x, I'm going to put -1. 2 times, use parentheses, -1 squared minus 2 plus 3 times -1 squared. What is -1 squared? Positive 1 minus 2. Remember, we're in gems. We are using order of operation, and we are simplifying our grouping. So what is 1 minus 2? -1. So I'm going to bring down my 2 times -1 plus 3. And now I have to take care of this exponent over there. What is -1 squared again? Positive 1. So I'm going to bring this down here, times 1. Okay, so I'm going to put a little arrow right here because I'm out of space. So now we have to multiply because we are on multiplication and division. 2 times -1 and 3 times 1. -2 plus 3 equals positive 1.